So what is the strain energy? What is the potential energy of the external load? So we apply what we have. So this is not very clear, you have to refer. So the main thing is I want to show to you the fact that at equilibrium, the total potential energy is the minimum value. So you add up these two, so you get the total potential energy. And then you apply the principle of minimum potential energy, which gives you these equations, only one equation, because this is a single degrees of freedom problem. Then the resulting is this equation, which is the equilibrium equations. Okay, so this one, we no need to go through all this to solve. We can use directly the concept of equilibrium, then we can get directly these equations. Okay, but we get this equation through PMPE. So PMPE actually gives you equilibrium equations that you need to solve for the unknown displacement. Okay. Now, if we now look at this total potential energy equation, okay, look at the total potential energy equation, which is equal to half K delta square, which is delta is the shortening minus P is the applied load multiplied with delta. So this is the equation for total potential energy. And it's a function of delta. Okay. So in this graph here, it shows to you the vertical axis is the total potential energy, and the horizontal axis here is the displacement delta. Here we assume some value so that we can plot this. So we make some assumption of the value here. If you look at your note, because this is already not clear here, 1 kilonewton is the load. The K is 200 kilonewton per meter. So class, the unit for K is force per unit length, stiffness, kilonewton per meter. So in order for us to be able to substitute the value and then calculate what is the value of delta P, total potential energy at different delta. So at delta is equal to 1, this is what we get, 2, 3, 4, 5, and then 6, 7, 8, and so on. So from here, what this example tries to show to you is that at delta is equal to 5, you get total potential energy minimum. It's a negative value, negative, 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 so minimum here. So according to principle of minimum potential energy, of all the possible delta can be 1, 1.2, 1.3, 1.4, 2, 2.5, 2.6, 3, 3.1, and something, anything. Delta can be any value. Okay. The one that corresponding to equilibrium with the loading applied, which is 1 kilonewton, is the point where the total potential energy is a minimum value. So other than that, you won't get minimum. So this is not the solution, this is not the solution, this is not the solution for equilibrium. This is also not the solution, this is also not the solution. The solution for equilibrium is delta is equal to 5 mm, where it makes pi p minimum. Okay. So this example illustrates that very concept that the equilibrium, the solution that gives us equilibrium correspond to the minimum value it makes the pi p minimum. Okay, so this is the purpose of this example. Very simple one, but we show this to you. So that is the thing that I would like you to take note of. So when you have equilibrium position, equilibrium solutions, that equilibrium solution makes pi p a minimum value. So other than that, that is not the solution. Okay? So that is the one that the purpose of this example. Okay, please go through that example in this particular notes here. Okay. Now let me go back. Okay.